first one is data scarcity. Uh, in data scarcity, current made VQA, or I have already discussed different type of data sets. They are often domain specific, focusing mainly on radiology and certain simplified or even synthetic question type that do not reflect the complexity or real clinical conversation. As a result, models trained on such datasets struggle when exposed to real world diagnosis scenario where questions require deeper reasoning. So our main aim is to develop enrich diverse dataset which composed of radiology, pathology, endoscopy, and longitudinal imaging. Next one is our next one objective is interactive made VQA dialogue mode. Uh, Objective 2 focuses on transforming made VQA from simple question answering into fully interactive multi-turn dialogue system. It aligned much more closely with real clinical practice. The goal is to develop a multimodal system that can read medical images, understand textual information, and incorporate structural patient data. Instead of answering isolated question, the model should maintain a conversation, provided follow-up responses, and adapt to the user interaction across multiple terms. Our third objective is the exploratory VQA with visual grounding. In objective 3, our goal is to design a explainable made VQA system that not only produce an answer but also provide visual and textual reasoning to justify the answer. Current made VQA model often behave like black box. They give prediction, but clinical have no insights into why those predictions are made. Uh, this lack of transparency is a major barrier to clinical adaptation. To address this problem, our system will generate attention map segmentation marks that highlights the exact region of medical image used for decision making. For example, when there is a fracture, the system should yes, see the highlight region on the in the distal ulna and visually mark the fracture site in the image. Our second, our last objective is symptoms to image QA. It expands the reasoning QA by multiple clinical data sources rather than relying solely on images. Real require information from diverse modality, including symptoms, lab finding. Their system will combine both structural data and unstructural data with medical image such realistic diagnosis surface. And there are many datasets as I discussed. One is expert CXR, but follow up question and clinical to better how during diagnosis. The overall goal those are the data this uh, like in the data like data sheet and to act with it. Or reading the to that uh, proper ethical identify clinical on architecture to do my research. Uh, Second one is third answer generation, which generate the answer. In multimodal visual encoder, in this part of architecture, the visual encoder is responsible for converting high resolution image into such high resolution medical image such as X-ray, CT scan, MRI, ultrasound image, and pathological slide into dense embedding. The architecture to achieve this, we will evaluate two types of encoding. First one is vision transformer VIT and medical domain pretend encoder. Second one is medical domain pretend encoder, that is bio VIL made clip, which already incorporate domain specific knowledge. Our second one is multimodal encoder, text and structural data. This system integrates textual data, structured clinical data, and medical image into a unified multimodal expression for clinical reasoning. Last one is cross-modal fusion and clinical reasoning. This model combines image, text, and structural embedding. Co-attention enables image to focus on important clinical word and allow to attend lab values. Special attention part uh, links such as connecting a city creativity to or lab abnormal. What are the equations for text and text to structure and selection? One is dialogue management. The core model shows multi-turn clinical. Primary role is to maintain uh, understand decided whether to request clarification or put their activity. The system may ask for short those surroundings. Finally, the educational and next evaluation mathematics and will be useful for medical domain. These are my data to create an interactive made VQA, extend a single turn VQA with clinical uh, fusion architecture that combines structured and unstructured data for those are the and budgets for my work. The project will be done under the collaboration of medical institute, particularly new medical institute at IIT-Kharagpur. To gain the access of different image data and clinical knowledge, some BTech and MTech students will be needed to help with data preparation, model construction, and evaluation. Close collaboration with the medical doctors will result in real-world QAPR, expert validation, and for the result, table 2